Okay, and he's going to tell you about UAVs and additive manufacturing. Thank you, sir.
Thank you. How you doing? So I was down at Northrop Grumman about 2 years ago and working on a documentary film there called The Hitler Stealth Fighter about the Horten 229. And I was talking to their guy, their additive manufacturing guy, and he very proudly took me over to his shop and showed me his equipment. And just told me straight out, he thinks that within his lifetime, and he wasn't a young guy, they would be growing aircraft and literally dusting them off, putting fuel in, and flying them away. And at the time, I kind of thought, okay, well, he's a visionary, and it sounds kind of like science fiction. But I'll tell you, in the 2 years since, I completely believe, now I don't know about his lifetime, that of course depends on how long he lives, but I think I'll see it, I really do. And so let me tell you a little bit about what I've done. So what I really wanted to do is I just set out to see what could be done with just low-end equipment, okay? I'm a member of Tech Shop, and they have these low-end 3D printers, and I thought, okay, is it possible to make actually a complete airframe? So I did a design in SolidWorks, which you see in front of you there. And let me see if I can figure out the navigation. And here's the low-end printer. I mean, this is a kit printer. This, I think, well, they got for free, but I think something like this at the time you could get for less than $1,000. And very simple. And I just designed somewhat with the machine in mind, because part of the problem currently is the machines are kind of limited. But how this thing works is it's got an extruder that's on an XY, a couple of stepper motors that control it in XY, and then it's got a build plate underneath, okay? So the extruder squirts out like a little 0.2 millimeter sort of extrusion of plastic, and then the build plate moves down. So you extrude one layer, and then the build plate pops down, you extrude the next layer, and it pops down again, you extrude the next layer. So you build up this part out of extruded, melted ABS plastic, okay? So part of the problem is that whole process, it's error prone. So if you're interested afterward, I got a whole bunch of parts, including some that are like fresh off the printer, so you can see some of the limitations and what things does. But a little bit about design. Of course, one of the great things is your complete design freedom. You can build any shape that you can imagine. If you can build it in SolidWorks or some similar tool, you can print it. But it's not quite that simple. Great thing is, like everything you see here, all this structure here, servo bay, mounts, hinges, control horns, everything, it's all printed right in, and you pull it off the printer, and it's, in theory, done. And nearly zero labor. The downside of that is it's actually a lot of print time. Even for a small part, you're talking hours of print time. So, we're not at nirvana yet, but it's still very interesting, and that's why I did it, because I just wanted to kind of understand the state of the technology. So, 3 minutes. Okay, and the machines currently are not that reliable. A lot of times you'll get false starts. You'll throw away a lot of parts, start over again. All right, but when it works, it's great. So the way it works now is you have shells. So the outer part of the part has shells, like I say, 0.2 millimeters. Usually you put at least 2 shells around the outside, and then the inside is fill, which by default the software produces this kind of honeycomb-shaped fill. So I did not design that. The software puts that in for you, and then you end up with a solid part that's got this honeycomb fill. Okay, so I knew I didn't have much time, so I didn't have many slides. So the promise is clear. I mean, you can see that this is going to be huge eventually. Right now, it's pretty limited. It's, the materials and the techniques and so on. Takes a lot of print time. The parts are kind of heavy. I mean, I built a lot of planes out of wood, and this is, it's really hard to get the weight down the same as wood with the same kind of strength and flexibility and all that stuff. And of course, we need bigger build volumes. I mean, if you're going to go out and spend 6 figures, you can get bigger machines, and there are people doing that. But, at a reasonable cost, at a reasonable time, we need stronger materials for sure. ABS has got its limitations, and that's the best material you got right now for low-end printers. So, time for a question? Any questions? Okay, I've got parts. If anybody wants to come by and see parts that are actually printed, I can show you samples. Okay? It has not flown yet. But check out the website. I'm going to keep posting stuff as I get closer to flying. Part of the problem is it takes a lot of print time to print these parts. I'm sharing the machine with 50 other people, and everybody's, abusing it, so it's broken half the time. And, Yeah. Okay. Yell it out.
Variables from machine to machine. Sorry, it's swallowed on your phone. Do you have problems with run-to-run, either the same machine or machine-to-machine problems if you only use one machine for your breaks? I run into significant issues on the small, not terribly complex parts for UAV.
Yeah. Well, I've only been using the one machine because it's the only one capable of ABS. There's another really common material called I think it's PV something. Anyway, it's not heat tolerant. So, the problems I run into is that the machine has to be adjusted just right in order for it to work. Everything has to be perfect. Build plate has to be perfectly level. The extruder has to be working just right. And if anything at all is wrong, you'll get the part will start and it'll fail, and then you start over again. So, but yeah, it's, the technology is amazing, but it still needs a lot of work. Thank you, sir. All right.